Hi guys, it's Mrs. Olshager breaking down expected value from today. So expected value is the average amount of wins or losses based on an event, a game, a turn, a spin, whatever you're working with here. So if I look at this spinner here, I see that I have 50% probability of landing on winning $0 and 50% of winning $4. So in 10 spins, right? Half of those spins I can predict will land here, and the other will land on $4, just based on the probability of the spinner. So that means 5 of these spins I would earn nothing, and then the other 5 spins I would earn $4. So my expected value would be $20 for 10 spins. Same idea for 30 spins. For 30 spins, I can predict that 15 will land here and 15 will land here based on the probability model. So 15 spins, I'll get nothing. And for another 15 spins, I'll get $4, which would leave me with an expected value of $60 on this spinner if I were to spin it 30 times. If I were to spin this 100 times, 50 of those spins, I'd predict I'd land on nothing, and the other I'd land on $4. Remember, this is just based on your probability. Half the time you're expected to land here, the other half you're expected to land here. Obviously, that's probably not how it would go in reality, but it's based on the probability model. So for this, I would be expected to win $200. Okay, let's generalize this idea. So for any amount of spins, okay? And so what we're noticing is that no matter what, notice 10 spins, $20, 30 spins, $60, 100 spins, $20. So it would be $2 would be the expected amount you'd win per each spin. Okay, so then part B says, okay, well, what's the expected value of one spin? So to find the expected value of one spin, you're considering the probability of each event occurring. Half of the time, you're going to win $0. The other half of the time, you're going to win $4, okay? And this is just for one spin, right? Expected value is for doing the action, the turn, one time. So this simplifies to 0. This simplifies to $2. So your expected value for one spin is $2. Okay, so let's continue to generalize that idea with one more practice problem. If we look at part B here, same idea. What would happen if we were to spin this 4 times? Okay, well, let's think about this. In 4 spins, you know that if we kind of think about this in quarters, right? One spin, you'd get $4, right? One spin, you might land on the $100. Another spin, because this is broken into 2 quarters, you're expected to land here twice, right? So that would be 2 times getting $0, right? So for 4 spins, I'm going to be expected to win here $104. Okay, for 100 spins, I could predict, based on the model, that 25 will land here, 25 will land here, and 50 will land here. So I have 25 of my spins landing on $4, 25 of my spins landing on $100, and 50 of my spins landing on $0. This would simplify. If I were to spin the spinner 100 times, I can predict that I'm going to win $2,600. So this is definitely a spinner I would want to play. If I was in Las Vegas, I would calculate an expected value. I'm expected to win if I play this 100 times. So it's worth my time. Now let's think about it for just one spin. Okay, if I were to spin this one time, what am I expected to win? Just that calculation here would be 1/4 of the time, you're gonna get $4. Another 1/4 of the time, you're gonna get $100. And then 1/2 of the time, you're gonna get nothing. Okay, this simplifies to $1. This simplifies to $25. and this is obviously $0. So in one spin, your expected value is $26. Because this value is bigger than 0, this would be a game I'd want to play because it's in favor of me winning on every single spin. Obviously, if I were to spin this one time, there's no way I can win $26. But if I were to play it 30 times, 40 times, I can use this to predict how much money I would earn on that many spins. Okay, I hope that kind of breaks down the 2 investigations for the day, and then will help you work through your turn-in problem.